In question number 1, it is given that what is C of n comma 1 in C2 plus dot 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 plus in Cn equal to, there are four options given. Okay, so look, first before we start with the solution, I want to discuss few concepts. That is, first of all, from binomial theorem we can say 1 plus x whole to the power n, the expansion of this term is in C0 1 to the power n minus 0 x to the power 0 plus in C1 x to the power 1 n minus 1 plus in C2 1 into minus 2 x to the power 2 plus dot 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 plus up to in Cn 1 n minus n x to the power n. Okay, now if I replace x with 1, I mean put x equals to 1, we will get 2 to the power n. 1 plus 1 whole to the power n means 2 to the power n. So the value for 2 to the power n is nc0 plus nc1 plus nc2 plus dot 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 plus ncn, right? Next I will discuss if there is a GP series. Okay, if there is a GP series where the first term is A and the common ratio of between two terms is R. That means the second term will be AR square dot 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 up to n terms. Up to n terms. Okay. This is in GP series. Now, how to find the nth term? So, Tn will be A r to the power n minus 1. Fine. And also, if I try to find the sum of these n terms, then sum of n terms, that is, the formula is A multiplied by r to the power n minus 1 by r minus 1, where r greater than 1. Okay, so these are few concepts we will use later in the solution part. That's why I have discussed it beforehand. Now let's start with the solution. So yes, it's given C of n comma n. This means in C1, in C2 plus up to in Cn, right? Now I can balance this expression by adding and subtracting in C0. Right, NC0. So yes, now look at the first this terms. So it is the form, it is the expansion of 2 to the power n, correct? So I can write 2 to the power n instead of this expression 2 to the power n minus NC0. Okay, so also NC0 will give us the value 1, 2 to the power n minus 1, because NC0 equals to 1. Okay, now look, this 2 to the power n minus 1 can be represented as 2 to the power n minus 1 by 2 minus 1, 1 multiplied by this. Okay, so if we compare this expression with the sum of n terms for a GP series, then we can get, so comparing it with a GP sum, that is A multiplied by r to the power n minus 1 by r minus 1, where r greater than 1. So here we get A equals to 1 and r equals to 2. So apparently r greater than 1, right? That's why. So 2 to the power n minus 1 can be written as, since it's a sum of an GP series where the first term is 1 and the common ratio is 2. That means we can write it as 1 plus 2 plus 2 square plus 2 cube plus dot 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 up to 2 to the power n minus 1. Okay. So this will, which will give us in terms in total, right? So yes, now let's check with the expression. It's option C is the correct answer. 1 plus 2 plus 2 square plus 2 cube dot 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 2 to the power n minus 1. In question number 2, it is given that what is the sum of the coefficients of first and last terms in the expansion 1 plus x whole to the power 2n, where n is a natural number. So in order to solve it, first we need to know few formulas. One of them is NCR. Okay, that is n factorial by r factorial multiplied by n minus r factorial. Okay, next one more is 1 plus x whole to the power n. So the expression of this expansion is NC0 1 to the power n minus 0 x to the power 0. NC1 1 to the power n minus 1 x to the power 1 plus NC2 x to the x square 1 to the power n minus 2 plus dot 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 plus up to NCN 1 to the power n minus n x to the power n. Okay, now in the given question, the expression is given as 1 plus x whole to the power 2n, right? So we will replace the exponent n with 2n. So it will become 1 plus x whole to the power 2n, 2nc0 1 2n minus 0 x to the power 0 plus 2nc1 2n minus 1 x plus dot 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 plus up to 2nc 2n 1 2n minus 2n x to the power 2n. Okay, so here therefore first term, that is this one. So 2n c0 1 whole to the power 2n minus 0 x to the power 0. This will give us the value 1, correct? Next, last term. Which one is the last term? This one is the last term. So 2n c2n 1 whole to the power 2n minus 2n x to the power 2n. So this will also give me the value 2nc2n means 1 1, it is x to the power 2n, right? Therefore sum is 1 plus x to the power 2n. Sum of the first term and the last term, that is 1 plus x to the power 2n. Now what is the coefficient of first term? Coefficient of first term, that is 1 because only 1 is there, and coefficient of last term. So only x to the power 2n is there. That means the coefficient is again 1. So therefore, sum of coefficients are 1 plus 1, that is 2. So here option B is the correct answer. It is given in question number 3, if the first term of an AP is 2 and the sum of the first 5 terms is equal to 1/4 of the sum of the next 5 terms, then what is the sum of the first 10 terms? Okay, so before I start with the solution, let me give you a small introduction about the concept of AP. We can consider a sequence, let's say A1, A2, A3 up to AN. The sequence is in AP. Okay, and the common difference we can refer it as D. Common difference means difference between two consecutive terms, that is A2 minus A1, A3 minus A2, and so on up to AN minus 1. We know the common difference is constant here. And how to find the general term? Let's say nth term of an AP is given by the formula is Tn. First term, if I consider A as the first term, so the formula is A plus n minus 1 into D, where D is the common difference and n is the position of the term that we are going to find it. Also, let me make you remember about the formula for the sum of first n terms. How to find the sum of first n terms? N by 2 multiplied by 2a plus n minus 1 into D. Also, there is another formula, n by 2 multiplied by a plus L, where a is the first term and L is the last term. Okay. L is the last term. So this is what I have explained you about AP. Now let's start with the solution. They have given that the first term is 2. So it's given the first term is 2. We can consider the first term as A0. Let's say A0, 2. Let's name it equation 1. Next, it is said that the sum of the first 5 terms is equal to 1/4 of the sum of the next 5 terms. Like sum of the first 5 terms means S suffix 5. We can denote it this way. It is equal to the 1/4 of the sum of the next 5 terms. Means if we find the sum of the first 10 terms and then subtract the first 5 terms, we will get the next 5 terms. So that is what it is. We can represent it that way. So let's do the cross multiplication. 4 is 5 is 10 minus is 5. So the relationship we are getting from here between S5 and S10 is plus S5 is 10, or 5 is 5 is 10. Okay, now let's put the formula. Is 5 means sum of the first 5 terms. So here we can write 5 multiplied by, since n is 5, so n by 2 plus 2a. 2a means the first term, so its first term is 2. 2 multiplied by 2 plus n minus 1, 5 minus 1 into D. We don't know the value of the common difference. We can refer it as D. Also, sum of first 10 terms means 10 by 2. 2 multiplied by 2 plus 10 minus 1 into D. Correct? Let's continue with the calculation further. 5, both 2 got cancelled and 2. So 4 plus 4D, also 2, 4 plus 9D. drop all the brackets, we will get 20 plus 20d equals to 8 plus 18d, correct? Now 2d and minus 12. If we bring all the terms, like terms to the left side, all the variables to the left side and all the constant to the right side, we will get 2d minus 12. That means the value of d is minus 6, right? So we have, it was given the first term, which is 2, and we got the value for common difference d. Now we can easily find the sum of the first 10 terms using the formula, correct? So let's put each and every value in the formula. Is 10, 10 by 2, 2 multiplied by 2 plus 10 minus 1 multiplied by minus 6. So here 5, 4 plus 9 multiplied by minus 6, 4 minus 54 minus 50. So we can write it as minus 250, correct? So minus 250 is the correct answer. Let me check. Yes, it matches with option B, correct? So here option B is the correct answer. Question number 4 states that consider the following statements. There are two statements given. If each term of a GP is multiplied by same non-zero number, then the resulting sequence is also a GP. 2. If each term of a GP is divided by same non-zero number, then the resulting sequence is also a GP. Which of the above statements is or are correct? Okay, so we will discuss about these two statements separately. First of all, let me tell you, multiplying or dividing with a non-zero number doesn't change the common ratio of the GP. Okay, so what I just said, that multiplying or dividing with a common zero number, with a, sorry, non-zero number doesn't change the common ratio of the GP series. Okay, so we can first consider a sequence. Let's say A1, A2, A3, dot, 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 up to AN is in GP series. Fine. So the common ratio can be found by A2 by A1, A3 by A2, or AN by AN minus 1, this way. Now, if each look at here, if each term is divided or multiplied by same non-zero number, it will be the same R value. Like it will got cancelled. It's just like a balancing expression. So the sequence will not change. What I just said, if each term is multiplied or divided by the same non-zero number, it will be the same R value. Okay, so the sequence will not change, right? That means here the resulting sequence is also a GP, then the resulting sequence is also a GP. Yes, so the both the statements are correct here. Option C is the correct one. It is given in question number 5, how many 5-digit prime numbers can be formed using the digits 1, 2, 3, 4, 5 if the repetition of digits is not allowed. First, let me make you remember what is prime number. Okay. So what is the definition of prime number? Prime numbers are those which are divisible by 1 and the number itself. Okay. So what will be the answer? That, okay, first let me tell you, not a single 5-digit prime number can be formed using the digits 1, 2, 3, 4, 5 without repetition. Why? Because when we add the digits, if we add the digits of the number that can be formed by using these digits 1, 2, 3, 4, 5, the result obtained will be, let me check, 1 plus 2 plus 3 plus 4 plus 5, you will get how much? You will get 15, correct? Now, 15 is divisible by 3. It's divisible by 3. So remember divisibility rule by 3. If we find that the sum of the digits of a number is divisible by 3, that means that number is also divisible by 3. So if the number is divisible by 3, that means this number is not a prime number. That's the reason why any number obtained as a permutation of this 5 digits, hence we can say any number obtained as a permutation of these 5 digits will be at least divisible by 3. And we have proved that divisible by 3 and cannot be a prime number for that reason. Okay. Be a prime number. That's why here option 0 is the correct answer. How many 5-digit prime numbers? There is none. So the correct answer is 0. It is given in question number 6, if f of x plus 1 equals to x square minus 3x plus 2, then what is f of x equal to? Okay. So the concept that is working behind is, that is, to get the value of any function at any point with respect to some other function, we need to manipulate the given function in such a way that we get the function that is needed. Look here, what is given? The function f of x plus 1 equals to x squared minus 3x plus 2, correct? Now, let x plus 1 equals to z, say, fine. And please factorize this polynomial x squared minus 3x plus 2. Let's do the factorization. plus 2. So after taking x common, so the factor says x minus 2, x minus 1, correct? Now we can write, we can balance it such a way so that I can write this x minus 2 as x plus 1 minus 3, also x plus 1 minus 2. Okay, now let's put it here. F of x plus 1 equals to x plus 1 minus 3, x plus 1 minus 2. X plus 1 minus 2. Okay. Now, since we have already assumed x plus 1 as z, we can put in the place of x plus 1, it will become z minus 3, z minus 2. Now, the given for polynomial, the given function changed into the variable of z. Okay. And what it's given that please find the value of f of x equals to. Okay, f of x equals to, now we can assume z as x, correct? Therefore, so let's say z as x, assume z equals to x, so it will become x minus 3, x minus 2, correct? Let's drop the brackets. C square minus 5x plus 6. So yes, that's the answer. F of x equals to x square minus 5x plus 6. Here option B is the correct answer. It is given in question number 7. If x square x minus 8 are in AP, then which one of the following is correct? There are 4 options given. First, let me give you a small insight about AP. Let us consider a sequence A1, A2, A3, and dot 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 up to AN. And this is in AP. So the relation between them, or which we can refer as common difference, D, that is the difference between two consecutive terms is always constant, and that is referred as D. So here we can write A2 minus A1, A3 minus A2, so 1 up to AN minus 1, correct? Now since it's given that x square x minus 8 minus 8, this is in AP, that means we can say that the common difference between two consecutive terms are equal, means constant. So x minus x square equals to minus 8 minus 6. So let's proceed with the equation steps. X square plus 2x plus 8 equals to 0. After taking common, minus 2x minus 8 equals to 0. So here we can further do the factorization. We will get x square minus 4x plus 2x minus 8 minus 4 minus 4. So we got the factors x minus 4 and x plus 2. That means either x minus 4 equals to 0 or x plus 2 equals to 0. So from here we can write x equals to 4 or x equals to minus 2. That means x belongs to the set minus 2 and 4. So here option 3, C is the correct option. X belongs to minus 2 comma 4. Question number 8 states that the third term of a GP is 3. What is the product of its first 5 terms? Okay, so here we're going to talk about GP, means geometric series. So let me first give you a small introduction about geometric series. Let's say here A1, A2, A3 up to AN, this is in GP. So what happened in GP? Usually we get the term in GP after multiplying a constant term with the preceding term to get the next term. That means the common ratio R refers here as common ratio. The common ratio is always constant. So we can mathematically, we can explain it as A2 by A1 will give us the exactly same value as A3 by A2 dot 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 this way AN by AN minus 1. Okay, so here we are given that the third term of a GP. So we randomly can take a series of 5 terms, correct? Let's say, and those random 5 terms will be A by R square, A by R, A, AR and AR square. Look here, since we started A by R square, if we continue multiplying R with the preceding term, we will get the next term. So A by R again multiplied by R, AR, AR square. So this is the GP we have considered here to solve this sum. Now so A be the third term, A be the third term, correct? We are already given with third term, that is 3. Therefore, A equals to 3. Now, if we try to find the product of all the 5 terms, so the product of the first 5 terms, let's find the product AR square, we will see the value will be A to the power 5. Since we got here A as 3, therefore 3 to the power 5 will give us the value 243. So here the correct answer is, what is the product of its first 5 terms? 243 is the correct answer. In question number 9, it is given that the element in the ith row and the jth column of a determinant of third order is equal to 2 multiplied by I plus j. What is the value of the determinant? Okay, so what the concept we are going to use in this solution, that is, if all the elements of a row or column are zeros, then the value of the determinant is 0. Since it is given that the element in ith row and jth column of a determinant of third order, we can denote it as Aij, third order, so 3 by 3 order matrix, square matrix. Say this is the element which is in ith row and jth column, that should be equal to 2 multiply I plus j, right? Now the determinant can be written as determinant can be written as, so if I put all those values, I'll get 1 plus 1, 2, 4, 6, 8, 6, 8, 10, 8, 10, 12. Okay, this way. Now we will perform some row or column division to evaluate the determinant value. So yes, we will start with row operation, that is R3 minus R1 R3 dash, and the new row, our second row will get by R2 minus R1. So yes, this will become 4, 6, 8, 6, 8, 10, 8, 10, 12 will become 4, 6, 8 are 2. So 2, 2, 2 again 4, 4, 4. Now we are going to do another row operation, that is R3 minus 2 R2 2R2. So it will become 4, 6, 8, 2, 2, 2, 0, 0, 0. Look, now since you can see that there is a row containing only 0 elements, the value 0, correct? So yes, the value of this whole determinant will be 0. So the value of the determinant is 0. What is the, yes, option A is the correct one. The value of the determinant is 0. In question number 10, it is given that with the elements 2, 4, 6, 8, all the possible determinants with these 4 different elements are constructed. What is the sum of the values of all such determinants? So look, first, what is the formula for arranging n number of elements in different way? Like if I say there are n number of elements and we want to arrange r elements from that in a different way, so the formula will be npr. That means n factorial by n minus r factorial. Okay. Here 4 elements are given, right? So we want to arrange these 4 elements in arranging in 4 different ways to get different determinants, right? So 4 elements can be arranged. 4 elements can be arranged in 4 factorial, or we say 4pr, 4p4 ways. Okay. So that will give us the value 4 multiplied by 3 multiplied by 2, 24 ways. So if I take 2, 4, 6, 8 as elements, and I can form 24 different determinants with these 4 elements. Okay. Now what will be the sum of those determinants values, right? So let me check few determinants. I can write it this way. First, let me take 8, 4, 2, 6. Okay, so this will give me 48 minus 8, 40. And with this way, also I can take a determinant 6, 4, 2, 8. Now this will give me the value 48 minus 8, again 40. Okay, now let me take another way. 4, 8, 6, 2. That means 8 minus 48, it becomes minus 40. Also, I can take it 2, 4, 8, 2, 6, 8, 4, 8 minus 48, another 40. Okay, so I have shown you 4 different ways to 4 different determinants. Now let me show you another few different determinants. 2, 6, 2, 6, and let's say 4, 8. So it becomes 12 minus 32. So minus 20. Okay. Now another way I can write it, 4, 8 and 4, 8 and 6, 2. So 32 minus 12. Now I'm getting plus 20. Okay. So separately, one more to another ways, 2, 8 and 6, 4. So 16 minus 24 minus 8. Also 4, 6 and to 8. That means 24 minus 16 plus 8. So yes, among this 24 is 24 ways. I have shown you 1, 2, 3, 4, 5, 6, 7, 8 ways. Right. Now let me check what will be the sum of those values, and I can assure you that same way, if you shuffle them out, if you shuffle the elements, you can form one more. I mean, you can form another 16, another 16 different determinants with them, but you will get the values either minus 8 or 8 or minus 20 or 20 or minus 40 or 40, but not other values. Okay, you will get no other values other than these values. So sum of values of all such determinants yes, let me check. 40 plus 40 minus 40. Here we will get another minus 40. I should write a minus here. Sorry, I have done this mistake. I haven't written it before. It should be minus 40. So 40 plus 40 minus 40, one more minus 40 plus 8 minus 8 plus 20 minus 20, right? Yes. Now I can see I will get the value of this summation as 0. So the answer of this question, that is, what is the sum of the values of all such determinants? That is 0. Option D is the correct answer. It is given in question number 11. What is the radius of the circle 4x square plus 4y square minus 20x plus 12y minus 15 equals to 0? 4 options are given. First, let me give you some information regarding circle. That is, the general equation of a circle is x square y square plus 2gx plus 2fy plus c equals to 0. Okay, this is the general equation of a circle for all values of g, f, and c. Okay, so from this circle, we can conclude that the center of the circle is minus g comma minus f. Fine. And the formula for finding the radius is root under g square plus f square minus c. Fine. Now we are going to compare this given equation with the general equation. So first, let me write it. 4x square plus 4y square minus 20x plus 12y minus 15 equals to 0. Okay, now let's name it equation number 1 and equation number 2. Let's compare both the equation. You can see in the general form, the coefficient of x square and y square is 1. So to compare both the equation to get the same form of the equation, we need to make the coefficient of x square and y square 1. So how can we do that? Let's take 4 common. X square plus y square minus 5x plus 3y minus 15 by 4 equals to 0. From here, we can write x square y square minus 5x plus 3y minus 15 by 4 equals to 0. Correct? Let's name it equation number 3. Now, from comparing 1 and 3, we can write comparing 1 and 3, we can get that we can further simplify it as x square y square plus 2 minus 5 by 2x Just to get the exact form of that 2gx and 2fy, 2 3 by 2y plus minus of 15 by 4 equals to 0. So now we can easily write g equals to minus 5 by 2, f equals to 3 by 2, and c equals to minus 15 by 4. Here we are going to find the radius, correct? So we will use this particular formula. Radius equals to root under g square plus f square minus c. So we will get 25 by 4, 9 by 4, 15 by 4. This will give us the value root under 49 by 4. That means 7 by 2 units. Fine. Further, we can write it as 3.5 units. Now let's check with the options. Yes, option D is the correct answer. The radius of the circle is 3.5 units. Question number 12 states that a parallelogram has 3 consecutive sides: minus 3, 4, 0, minus 4, and 5, 2. The fourth vertex is, so here we are going to find the fourth vertex. First, let me draw a parallelogram. So we can name it as A, B, C, D, correct? So the vertex are minus 3, 4, 0, minus 4, 5, 2, and we can assume the coordinate of D as x, y, correct? So here there is one important properties regarding parallelogram, like the diagonals bisect each other, correct? So let's say O is the midpoint. If the diagonals bisect each other, that what does it mean? That AO equals to OC and OD equals to OB. So first we will find the coordinate of O. Find the coordinate of O. So what we can do, for let's with the midpoint theorem, we can find the coordinate of O, that is minus 3 by 5, 4 plus 2 by 2. So it will give us the value 1, 3. So this is the coordinate for midpoint O. Now with help of this coordinate, we can easily find the value for x and y. So x plus O by 2 equals to 1, and also y minus 4 by 2 equals to 3. From here we can write x2 and y 6 plus 4, that means y equals to 10. So it means the vertex of D is 2, 10. So here option A is the correct answer. In question number 13, it is given that if the lines y plus px equals to 1 and y minus qx equals to 2 are perpendicular, then which one of the following is correct? Okay, so first we will discuss about few important points regarding a straight line. We know that there are various type of representation of the equation of a straight line. So first we will pick up slope intercept form for our discussion. Slope intercept form of a straight line. In this form, we can represent the equation of a straight line like y equals to mx plus c, where m is the slope of the line, and C is y-intercept. Okay, y-intercept. Now, when two lines are perpendicular, this is the mathematical representation of perpendicularity of two lines. So we know the product of the slope is always 1. Let's say the slope for this line is m1 and slope of this line say m2. So if they are perpendicular, then the product of their slope will be m1, means m1 multiplied by m2 equals to -1. Okay, so this concept we are going to use in order to solve this particular equation. So here y plus px equals to 1. Y plus px equals to 1. We will compare this equation with the general slope intercept form. Let's find the slope first. From here we can write y equals to minus px plus 1. Therefore, m1 equals to minus p. Now write another equation, that is y minus qx equals to 2, correct? So it becomes y equals to qx plus 2. Comparing the same equation with the general slope intercept form, we can write that, let's say m2 be the slope of that line, m2 equals to q. Now, since they said that the lines are perpendicular, that means since lines are perpendicular, that means m1 multiplied by m2 equals to -1. Let's put all the values, minus pq equals to -1. So we can write it as pq minus 1 equals to 0. Now let's check with option it matches with yes, option C. So pq minus 1 equals to 0. This relation established. In question number 14, it is given if A, comma B and C are in AP, then the straight line AX plus 2BY plus C equals to 0 will always pass through a fixed point. And we need to find that fixed point, the coordinate of the fixed point. So since it is the concept of AP is given in this particular equation, first we will talk about the concept. So if we say A1, A2, A3 and so on up to AN, this equation is in AP. That means the difference between two consecutive terms are equal and constant, and we refer that difference as common difference. Let's say that is D. So D can be written as A2 minus A1, A3 minus A2 up to AN minus 1. Fine. Now given A, B, C are in AP. That means B minus A equals to C minus B. From here we can write 2B equals to A plus C. Fine. Further we can write it as A minus 2B plus C equals to 0. Let's name this equation 1. Also, it is given the equation of the straight line given as AX plus 2BY plus C. AX plus 2BY plus C equals to 0. So here, both the equation, let's name it equation 2, both the equations we can compare because the coefficients refers the same constraints, which is ABC. So comparing 1 and 2, we can write here x equals to 1 and y equals to minus 1. So the fixed point is like if since this point is lying on the line ax plus 2by plus c, so the value of xy will satisfy the equation. So if we uh, mm, put the value in place of x and y, we will get this relationship. So the fixed point is 1 minus 1. So here option D is the correct answer. In question number 15, it is given that if the image of the point minus 4 comma 2 by a line mirror is 4 comma minus 2, then what is the equation of the line mirror? First, we will discuss few concepts regarding straight lines. Okay. First of all, when two lines are perpendicular to each other, the product of their slope is minus 1. If M1 is the slope of this line and M2 be the slope of this perpendicular line, then mathematically we can say that the product of their slope is equals to minus 1, right? Now, one more thing, like when a line passing through two distinct points, x1, y1 and x2, y2, the slope of that line should be, if I say m is the slope of that line, I can address m as y2 minus y1 by x2 minus x1. This is the formula for finding slope of a line when any 2 points that lies on that particular line, any two distinct points that lies on that particular line is given. Also, equation slope form. Okay, we can represent the equation of line in various way. One of them is equation point slope form. Equation of the line, we can represent equation of line various way. One of them is point slope form. Point slope form, like in that equation we will be given one random point that lies on that line and the slope of that particular line, and the representation is y minus y1 equals to a multiplied by x minus x1, where x1 and y1 lies on that line and m is the slope of that line. Okay, now in this case, for knowing the equation of the line mirror, its slopes needs to be determined first. So we will start this way. Now let me draw the scenario. Let's say here, this is the line mirror. Okay, line mirror, right? And here minus 4 comma 2, the given point, and another way here 4 comma minus 2, this is the image. From physics, we can say that the distance of the object from the mirror is equal to the distance of the reflection from the mirror. That means this distance is equal. So if there is a point on the line mirror, let's say A will be the midpoint of these 2 points, right? So we can easily find the coordinates of A with the help of the midpoint formula. That formula is x equals to x1 plus x2 by 2 and y equals to y1 plus y2 by 2. So let me find the coordinates of A. Coordinate of A, that is minus 4 plus 4 by 2 plus 2 minus 2 by 2. It's 0 comma 0. Now from the equation we can easily say that the line mirror is perpendicular to the line joining these 2 points, right? So the slope, the relationship between slopes of these two lines should be the product of this of their slope is minus 1, correct, as we have seen that. So slope, find the slope of the line joining minus 4 comma 2 and 4 comma minus 2. So slope of the line joining minus 4 comma 2 and 4 comma minus 2, y2 minus y1 by x2 minus x1. So minus minus a plus, it become plus. Now minus 4 by 8, that is minus half, correct? Since as the mirror line is perpendicular to this line, as the mirror line is perpendicular to this line, so we can say that m multiplied by minus half equals to minus 1. That means the value for m is 2, correct? Now we got the slope and one point that lies on the mirror line, right? Now we can easily find the equation of the line mirror. Hence the equation of line mirror is y minus y1 equals to a multiplied by x minus x1, or y equals to 2x. This is the equation of the line mirror. Now let me check the options. Yes, option B is the correct one. Y equals to 2x. In question number 16, it is given that tan inverse x plus cot inverse x equals to pi by 2 holds when x belongs to. Now we are going to check the domain for the x. Okay, so first of all, we are going to use some formulas from inverse trigonometric equation, trigonometry. So one of the formula that we will be using, tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy, right? Another one is cot inverse x equals to tan inverse 1 by x. Fine. Now given expression is tan inverse tan inverse x plus cot inverse x equals to pi by 2. Or now cot inverse x can be written as tan inverse 1 by x. Pi by 2. Now use the formula of the sum formula. We will get tan inverse x plus 1 by x minus pi by 2, or tan inverse x plus 1 by x by 0 pi by 2, right? Tan inverse. Now since here we are dividing by 0, right? But we cannot divide by 0. It becomes undefined, right? So finite undefined, that equals to pi by 2. Now we know, since we got the value of undefined, it's true that tan pi by 2 gives us the value undefined, correct? Now we can say that R belongs to, this is only true for all x belongs to real number set. This is true for all x belongs to real number set. So here option A will be the correct one. Question number 17, given that if tan A equals to 1 by 7, then what is cos 2A equal to? There is a relation between cos 2 theta and tan theta. That is, in trigonometry formula, we know that cos 2 theta equals to 1 minus tan square theta by 1 plus tan square theta. So in this equation, we putting the value of theta in place, putting the value of theta in place of A. Further, we can write the same formula as cos 2A, since here we are given with the value of tan A. So we can consider the angle A, 1 minus tan square A by 1 plus tan square A, correct? Given tan A equals to 1 by 7. Let's put the value here. 1 by 1 plus 1 by 7 whole square. 1 by 49. 1 plus 1 by 49. 49 minus 1, 49 plus 1, 48 by 50. Further, we can simplify this. We will get 24 by 25. Therefore, cos 2A equals to 24 by 25. It matches with option A. So option A is the correct answer. It is given in question number 18. The sides of a triangle are m in and root under m square plus n square plus m in. What is the sum of the acute angles of a triangle? First, let me explain you something. First, let's draw a triangle. Okay, A, B, C. Let's say the length of the sides are A, B, and C. And here, theta is the angle between the side B and C. Or we can say that theta is the angle between the side A and B. Okay. Then we can denote the value of cos theta as, since theta is the angle between the side A and B, it's theta 1, and theta is the angle between the side A and B, we can write it as A square plus B square minus C square by 2AB. This is the formula. Fine. Now, with reference to this problem, let's draw another triangle. And here, let's say this is side m in, and the another side is m square plus n square plus m in. Okay. Let us assume that m and n both are 1 unit. Okay. That means the third side will become root 3 units. Fine. So using the cosine rule, we can write, if say theta is the angle in between the sides m and n, we can write cos theta as 1 square minus root 3 whole square by 2 1 multiplied by 1. 2 minus 3, 2, it becomes minus half. Okay. So cos theta equals to, since the 60 degree, cos 60 degree give us the value minus half. So we can write it as this way, minus of cos 60 degree. Minus of cos 60 degree means here we are going to explain the concept of angles. Look here, cos 60 degree means which quadrant? It is in the, let's say, either in the second quadrant or the third quadrant. Fine. Now this cos 60 minus cos 60 degree can be explained as, can be written as 290 degree minus cos 60 degree. Okay, why? Because since it is minus, let's say in the second quadrant, so first one rotation, two rotation, but since it's 60 degree, it's not crossing the quadrant, it's there in the second quadrant, so that's why cos 2 multiplied by 90 degree minus 60 degree, and it will give us the value cos 120 degree. So from here we can say therefore theta equals to 120 degree. So this angle is 120 degree, correct? Now if we got one angle, we will get the sum of the raised two angles from the angle sum property. And since this angle is obtuse angles, obviously the raised two angles will be acute angles. Therefore, the sum of the acute angles of the triangle from angle sum property, we can get it as 60 degree. Let's check the options. Here, option B is the correct answer. Question number 19 states that what is the area of the triangle ABC with sides A 10 centimeter and C 4 centimeter and angle B equals to 30 degree. Okay, so here first let me draw a triangle. We know a few different formulas for finding out the area, right? One of them is Heron's formula, and there is one general formula like half into base into altitude, correct? Now, if in a triangle we are given to the sides and one angle that is included between any two sides, let's say theta, okay, then we can conclude that the area of triangle ABC can be found by half of AB, or okay, see here BCB and sine theta, means half into product of two sides with the multiplied by the angle value of the sine theta. I mean theta is the angle between two given sides here, so half into CB into sine theta, correct? Since here we are given with two sides A and C and the angle B is 30 degree, that means it will looks like this: A, B, C. So C here is 4 centimeter, this one is 10 centimeter, and this is 30 degree, correct? So how to find the area of a triangle? Area of triangle ABC equals to half into C into A into sine B, angle B. Let's put all those value. It's given that A equals to 10 centimeter and C equals to 4 centimeter, correct? So half 4 multiplied by 10 multiplied by sine 30 degree. So here 2, 10. We know the value of sine 30 degree is half. So 10 centimeter square is the answer. Let's check with the options. Yes, option C is the correct one. It is given in question number 20. Consider the following statements. Statement 1, set A contains 135 and set B contains 247. These two are equivalent sets. And question statement 2, A contains 159 and B contain again 159 are equal sets. Which of the above statements is or are true? First, let me give you the concept of equivalent sets and equal sets. Okay, so equivalent set means when two sets. Okay, first of all, tell me what is about the what is the cardinal number? Cardinality of a set. Cardinality of sets. What does it mean? Like if a set is containing three numbers or three elements or five elements, that means the cardinality of set is 5. If a set is containing 5 elements, the cardinality of set will be, let's say the set is A, the cardinality of the set will be 5. So cardinality of set means number of elements a set have. Okay, so here in equivalent set, when two sets are called equivalent sets, that means A and B, like say A and B are two sets, so A and B have the same cardinality. So A and B have the same cardinality. Okay, that means n of A equals to n of B. If these two have same cardinality, then A and B are called equivalent set. Correct? So let's check here. Here there are three elements in A. That means n of A is 3. Correct? Also, there are three elements in B as well. So that means n of B equals to 3. So from here we can say therefore n of A equals to n of B. That means they are, therefore A and B are equivalent set. Correct? So statement 1 correct. Now let's check statement 2. Fine. So look here, what does it mean? Equal set. What does it mean? Two sets, let's say for example A and B, can have equal element. I mean each element of A is also the element of B. Or we can say that two sets are the subsets of each other. Then they can be said equal set. Okay, like equal set means A equals to B. So if A subset B and B subset A, that also implies that A equal to B. Like I'm telling you, A equals to 1, 2, 3. Also, B equals to 1, 2, 3. That means each element of A is equal to each element of B. So here A and B are called equal sets. So we can say A equals to B. Also, since they're equal sets, that means A is the subset of B and vice versa. B is the subset of A. So let's check here in this case A 1, 5, 9. Correct? So here 1, 5, 9 belongs to set A. And also you can see that there are 2 5s, 2 9s, but the numbers are same. Again 1, 5, 9. Numbers are not different. Correct. So here 1, 5, 9 belongs to set B. There is no new number apart from 159 that is introduced in B. Correct? So all the elements are same. That means A equals to B. They are equal sets. So also statement 2 is correct. So here we can say, since statement 2 correct, statement 1 correct, we can say that both 1 and 2 are correct. Option C is the correct answer. In question number 21, it is given that consider the following statements. First, the null set is a subset of every set. Second, every set is a subset of itself. Third, if a set has 10 elements, then its power set will have 124 elements. Which of above statements are correct? Now look here. First, let's talk about null set. Correct? Null set. Now null set looks like this, okay, with no elements inside it. Now it represented using phi, this sign phi. So first we have to discuss about that null set is a subset of every set. Okay, so let us consider a set A contains 1, 2, 3, the first three natural numbers. Now think about it. Okay, there is a very funny way to understand this concept. Look, null set contains nothing, correct? Null set contains nothing. So, and what does A contain here? 1, 2, 3, and nothing. Because when we find the intersection of A and null set, if we try to find the intersection of A and null set, we will find what? Nothing. We will find null set, correct? So, and that intersection set is a subset of each of the original set. Each of the original set. That's why we can say that null set is a subset of every set, because every set has nothing. So here we can write that null set is a subset of set A. So null set is a subset of every set. So it's proof that null set is a subset of every set. Also from this statement, we can say that null set is a subset of null set itself. Null set is a subset of null set. So we can write, correct? Since both the sets have nothing, that means we can say, therefore we can say that every set is a subset of itself. Fine. So first two statements got proved that they are correct. Now come to the third statement. Okay, so first let me tell you how to find the number of subsets of a set with n elements. So the number of subsets of a set with n elements is 2 to the power n. Okay, so here how many elements are there? 10 elements are there. So from 3 we can write, if n equals to 10, then the power set will have how many elements? 2 to the power 10 elements. So eventually 2 to the power 10 will give us the value 1024. So here all three statements are true. So we can mark option D. 1, 2, and 3 statements are correct. In question number 22, it is given that let R be a relation defined as XRY if and only if 2x plus 3y equals to 20, where x comma y belongs to natural number set, that is n. How many elements of the form x comma y are there in R? Now, since it's x related to y with relation R, x is related to y with relation R, we can express it as x ry, that is x comma y belongs to R in this relation. Now here the given expression or the condition is, we can say that 2x plus 3y equals to 20. Now x and y belongs to natural number set, right? That means if we put x equals to 1, we have to get here the values of x and y uh, in counting numbers, in natural numbers. So it becomes 3y 20, y will be 6. Now if I put x equals to 4, it will become 8, 3y 20, y equals to 4, and put x equals to 7, 14, 3y 20, y equals to 2. But no other values other than 147 give us the value for y in natural number set. So the relation, from here we are getting the pairs of xy, that is 1 comma 6, 4 comma 4, and 7 comma 2. The relation R can be written as that is 1 comma 6, 4 comma 4, 7 comma 2. Okay, so that means there are 3 elements in the form xy in R, 1, 2, 3. So yes, B, option B is the correct one. How many elements of the form x comma y are there in R? There are 3 elements of the form x comma y in R. In question number 23, it is given that consider the following statements. A function if z to z, integer z to integer z, defined by f of x equals to x plus 1 is 1, 1 as well as onto. And the second statement is a function if from natural number set to natural number set, defined by f of x equals to x plus 1 is 1, 1 but not onto. Which of the above statements are correct? First of all, we will discuss about 1, 1 and onto mapping. So 1, 1 mapping means 1, 1 mapping means a function if defined from a to b, a function if from a to b is said to be a 1, 1 mapping or 1, 1 function if different elements of A have different images in B. Okay. So if I say that if A to B is 1, 1, that implies that A not equals to B implies that f of A not equals to f of B for all A comma B belongs to A. Also, it implies that if f of A equals to f of B, that means A equals to B for all A comma B belongs to A. That is the definition for 1, 1 mapping. Okay. And also, onto mapping is a function if A to B is said to be an onto mapping if and only if for each B belongs to B set, there exists A belongs to A, such that such that f of a equals to b. What does it mean? It actually means that each element in the codomain of f has a preimage. Each element in the codomain of f has a preimage. Fine. Now let's proceed with the solution. Here they have said a function integer set to integer set defined by f of x equals to x plus 1 is 1 1 as well as onto, right? So let's write it. A function f z to z defined by f of x equals to x plus 1 is 1 1 as well as onto, right? That means if f of, we can define f of x equals to yes x plus 1. So that means let's say x1 and x2 both belongs to z. So we can write x1 equals to x1 plus 1 and f of x2 equals to x2 plus 1. Since this 2 is 1 1, therefore now f of x1 equals to f of x2. So that means x1 plus 1 equals to x2 plus 1. So x1 equals to x2. Okay. So if f is 1 1 function. Okay. So therefore f is 1 1 function. Okay. Now consider f of x equals to y. So we can write y equals to x plus 1. So from here we can also write x equals to y minus 1. So f of y minus 1 means y minus 1 plus 1, that will give us the value y. Therefore f is onto, because y has a preimage. Okay. So if f of y minus 1 giving us the value y, so f is onto. Now if we discuss from the point of view of examples, since it's an integer set, that means let's say z. So -3, -2, -1, 0, 1, 2, another z set z, 3, 2, 1, 0, -1, -2. Now look here, if -3 map to -3 plus 1 -2. Okay. -2 map to -1. Okay. 0 map to 1, -1 map to 0, 1 map to 2, and 2 map to 3. This way each and every element, different elements have different images. That's why it's 1 1, and each and every element in the codomain of f has a preimage as well. That's why it's 1 1 and onto. Okay, so statement 1 is correct. Okay, now let's check statement 2. A function if defined from natural number set to natural number set, defined by f of x equals to x plus 1, that is 1 1 but not onto. Okay, so let's calculate. If x1 and x2 belongs to a natural number set, so f of x1 gave us x1 plus 1 and f of x2 give us x2 plus 1. Since it's 1, 1, we can write now f of x1 equals to f of x2. x1 plus 1, x2 plus 1. So x1 equals to x2, correct? So f is 1, 1 function, right? Now, clearly, since f of x is defined as x plus 1, so clearly we can say f of x equals to x plus 1, that is always greater than equals to 2 for all x belongs to natural number set. How? Okay, let me show you. Here in from natural number set to natural number set, let's say 1, 2, 3, 4, 5, also 1, 2, 3, 4, 5, right? Now 1 map to 2, 2 map to 3, 3 map to 4, 4 map to 5, 5 map to 6. This way it will goes on. But look here, in this case, 1, which is in the codomain set, 1 doesn't have any preimage in its domain, right? 1 doesn't have any preimage, correct? So f of x doesn't assume the value once. So f of x doesn't assume the value 1, right? So it can't be a onto function, because if it's a onto function, then what is the definition of onto? Each element in the codomain of f has a preimage, but it's clearly evident that 1 has no preimage, right? That means it violates the condition of onto. So f is not onto function, right? So as it states that f is not onto function. Okay, so as it states that the function f from integer set to integer set defined by f of x equals to x plus 1 is 1, 1 as well as onto. We have already shown that the statement is correct, and also for the statement 2, that the function natural number set to natural number set defined by f of x equals to x plus 1 is 1, 1 but not onto, that is also correct. So here option C, both 1 and 2 correct. That is the correct option. In question number 24, it is given, consider the following in respect of a complex number z. There are two statements given. First one is z inverse bar equals to z bar inverse. And the second one is the product of z and z inverse equals to mod z whole square. Which of the above is or are correct? First, let me discuss about few concepts regarding complex number. That is, consider z as a plus ib. Okay, here z bar means the conjugate of z. Okay, z bar is the conjugate of z. That means z bar can be written as a minus ib, right? Also, multiplicative identity of this two is multiplicative identity of z and z inverse is 1, right? Now, also z, the product of z and z bar, that is a plus ib and a minus ib, will give us a square minus I square b square. We already know I square equals to -1. That means a square plus b square. Okay. Now start with the given statements. First statement, given first statement, that is Z inverse bar equals to Z bar inverse, right? Yes. So let me proceed with the solution. Now consider Z equals to A minus IB. Okay. So Z inverse will be 1 by Z, right? So here 1 by A minus IB. Now we need to rationalize this. We will get A plus IB. To rationalize, for rationalizing, we will multiply both numerator and denominator with the conjugate of A minus IB. So we will get A plus IB by A square plus B square, right? Next, Z inverse bar. So the conjugate of this complex number, the complex number Z inverse will be A minus IB by A square plus B square. Okay, let's name it equation number 1. Now, Z bar, if Z is A minus IB, Z bar should be A plus IB. So Z bar inverse will be 1 by A plus IB. Okay. Further, we can rationalize it. We will get A minus IB by A square plus B square. Let's name it equation number 2. Now look here, Z inverse bar and Z bar inverse both are giving us the same value. That means from equation 1 and 2, we can say that statement 1 is correct. Statement 1 is correct. Okay. Now let's check with the second statement. That is Z, the product of Z and Z inverse equals to mod Z whole square. First of all, let me, if Z equals to A plus IB, then mod Z, modulus of this Z will be root under A square plus B square. So obviously mod Z whole square will be A square plus B square, right? Now let's start with the solution. So here consider Z as A minus IB. We can consider this. So Z inverse will be A plus IB by A square plus B square, right? Now let's do the find the product Z and Z inverse. A minus IB with A plus IB, A square plus B square. Yes, we will get another A square plus B square. So it becomes 1. But we have seen that Z modulus of Z square giving us another value. It's not equals to 1. So yes, therefore statement 2 is not correct. Statement 2 is not correct. So from the conclusion, we can say that only first statement, that is 1, is correct. So option E is the correct one. It is given in question number 25. Consider the following statements in respect of an arbitrary complex number Z. The difference of Z and its conjugate is an imaginary number. The sum of Z and its conjugate is a real number. Which of the above statements is or are correct? There are 2 statements given. We need to discuss these 2 statements and check whether they are correct or not, and according to that we will decide which option will be the correct among this four. Okay, so in order to solve this sum, first let me discuss about complex number, the concept of complex number. Let's say z is a complex number, z equals to I x plus I y be a complex number, where x is called the real part of the complex number, or we can say this way. And here y is called the imaginary part. Imaginary part, or can be denoted as this way. Why called imaginary part? Because y is associated with I. Here I is the complex number, I is the imaginary number, whether I square give us the value -1, correct? So that means I equals to root of -1. That is the value for I. So here y is the imaginary part. Now conjugate of z can be expressed as conjugate of z can be expressed as z bar. And how can we write that value? X minus iy. Just the sign before the imaginary part will changed. Okay, so let's start with the calculation. First it is given in statement 1, the difference of z and its conjugate is an imaginary number. Okay, let's check it. First, the difference of z and its conjugate is an imaginary number. Consider z equals to a plus ib. Let's name it equation number 1. Okay. Next, conjugate of z. Conjugate of z, that is z bar, that is equals to a minus ib. Just the sign before the imaginary part will be changed. Let's name it equation number 2. Now the difference of z and its conjugate. So we need to find the value, difference value. So equation 1 minus equation 2. Let's do this. Z minus z bar, a plus ib minus a, minus of minus plus ib. Both a got cancelled. We will be left with the value 2ib. Okay, so look here, there is no real part, correct? Only 2ib. So 2b is associated with I. That means it's completely purely imaginary number, purely imaginary value. So it is clear that the difference, therefore, the difference of z and its conjugate is an imaginary number, correct? So we can conclude that this statement is true. Okay, now let's talk about the next statement. The sum of z and its conjugate is a real number. Okay, let's check it. First, we have already considered the complex number z, and we got the conjugate of z also, which is z bar. This time we are going to add them out. Fine. So z plus z bar will give us the value a plus ib plus a minus ib. We got 2a. Look here, there is no imaginary part because there is no term which is associated with I. 2a, this is purely real part. So it is clear that the sum of z and its conjugate, means z bar, is a real number. Okay, so 2 correct and also 1 is also correct. So both the statements are correct. So here option C is the correct answer. It is given in question number 26. What is the modulus of the complex number I to the power 2n plus 1 multiplied by minus I to the power 2n minus 1, where n belongs to capital N, means the set of natural numbers, and the value of I is root under minus 1. Okay, so we already know that what is the value for I, that is root under minus 1, correct? That means I square will give us the value minus 1. I cube can be written as I square multiplied by I. So minus 1I minus I. This way we can find uh, the value of I with different exponential power, correct? Now what expression we are given here, I to the power 2n plus 1 minus I to the power 2n minus 1, correct? So let me simplify it some way that this can be written as 2n minus 1 minus of 2n minus 1, correct? So when the base is same, so we will add the powers if they are in multiplication relation. So I to the power 4n minus 1 whole to the power 2n minus 1. So this is the simplified form expression of the given expression. Now let's think, put n equals to 1. Okay, so if I put n equals to 1, we will get the value of I to the power 4 minus 1, 2 minus 1. So I to the power 4, let me tell you, whenever the power is an even number, whenever the power of the I is an even number, we will get always, okay, I square multiplied by I square. So minus 1 minus 1, we will get 1. So I to the power 4 will give us the value 1. Okay. And 1. And here minus 1 whole to the power 1 will give us minus 1. That means the total value is minus 1. Let me check it another way. N equals to 2. Correct. So here I to the power 8, 4 to the n minus 1, 2 to the 4 minus 1. So I again, since I to the power 4 gives us the value 1, so 1 whole square I to the power 4 whole square again will give us the value 1, and here minus 1 whole to the power 3. So 1 minus 1 will give us minus 1. So by putting any value of n, we get minus 1 as the value of the expression. Hence, the modulus of the given expression is minus 1. Okay. So here option A is the correct answer. In question number 27, it is given that if alpha and beta are the roots of the equation 4x squared plus 2x minus 1 equals to 0, then which one of the following is correct? Before we start with the equation, with the solution, I will discuss few concepts about general quadratic equation. The general form of an quadratic equation is ax squared plus bx plus c equals to 0. And if I say alpha and beta are the two roots of this equation, that means if I put alpha in or beta in place of x, it will satisfy the equation. Okay. And what are the relationships between roots and the coefficients of the equation? That is alpha plus beta equals to minus b by a, and alpha beta equals to c by a. Okay. One more important formula we are going to discuss, that is quadratic formula, or another name is Sridharacharya formula. Like I can find the value for x with the help of this formula, minus b plus minus root under b square minus 4ac by 2a. Here b square minus 4ac, this expression is called discriminant, right? Now given 4x square plus 2x minus 1 equals to 0. This quadratic equation is given. By comparing it with the general form, I can write a equals to 4, b equals to 2, and c equals to minus 1. Correct? So if alpha and beta are two roots, we can write alpha beta equals to minus 1 by 4. So from here, beta equals to minus 1 by 4, right? Now also sum of roots are alpha plus beta equals to minus 2 by 4, that means minus half, right? Now let's substitute with the value of beta, that is alpha minus 1 by 4 alpha equals to minus half. So from here I can write 4 alpha square plus 2 alpha minus 1 equals to 0. Okay. Now we can use the quadratic formula. Okay. So here the variable is alpha. Now comparing with the quadratic formula, I can write minus 2 plus minus b square 4 minus 4ac by 2a. So I got the value of alpha as minus 1 plus minus root b by 4. Now let's consider the positive value for alpha, that is minus 1 plus root 5 by 4, and so beta is minus 4 by alpha. That means it will become minus 1 minus root 5 by 4. So after taking common minus 1, I can write 5 by 4. Okay. So first start with the first expression, that is beta equals to minus 2 alpha square minus 2 alpha. Let's check with this one. So here's minus 2 alpha square minus 2 alpha. Let's put all those values. 5 by 4 whole square minus 2 minus 1 plus root 5 by 4. So here minus 2, 1 plus 5 root 5. After expanding it by a plus b whole square form, a minus b whole square formula, 4 equals to, so it becomes minus 3 plus root 5 by 4 plus 2 by 4 minus 2 root 5 by 4. Intentionally I have make the denominators as 4. It will help us to do the further calculation. 3 plus 2, 5, that means 4 minus 1 minus root 5. So after taking common minus, I can write it as 4. That means it is equals to beta. Look at the value for beta. So yes, beta, it equals to beta. So it satisfied the relation beta equals to minus 2 alpha square minus 2 alpha. That means option 1 is correct. So yes, option 1 is correct. It is given in question number 28 that if one root of 5x square plus 26x plus k equals to 0 is reciprocal of the other, then what is the value of k? So first let me discuss about quadratic equation. Let us consider the standard form of an quadratic equation be ax square plus bx plus c equals to 0. Okay, and let alpha and beta are the two roots of this quadratic equation, alpha and beta, right? Now the relationship between the roots and the coefficient of variable that holds, that is the sum of roots of a quadratic equation is given by minus b by a, and the product of the roots is given by c by a, right? So here minus of coefficient of x by coefficient of x square, and also constant term by coefficient of x square, correct? Now let's start solving this particular sum step by step. If one root of 5x square plus 26x plus k equals to 0, 5x square plus 26x plus k equals to 0. Let's say one root is alpha. Okay, let alpha be a root of the given polynomial. So the other root is reciprocal of this root. So the other root must be 1 by alpha, right? Now, if we compare this equation with the standard form, we will get a equals to 5, b equals to 26, and k equals to, or c equals to k. Okay, so let's apply all the relationships, this and this. That means alpha plus 1 by alpha equals to minus 26 by 5, and alpha, the product of alpha and 1 by alpha is k by 5. Now from here we can write both the alpha got cancelled, k equals to 5, right? In this sum we are required to find the value for k. So here option C is the correct answer. The value of k is 5. In question number 29, it is given that in how many ways can a team of 5 players be selected from 8 players so as not to include a particular player. So in this particular sum, in order to solve this, we are going to use the concept of combination, correct? Let's say there are n elements, okay? Total number of n elements. And among those n elements, we are going to take a group of r elements, or take a combination of r elements. Okay, so how many ways that can be possible, that could be possible? The formula is ncr. NCR, and NCR means n factorials by r factorials multiplied by n minus r factorials. Okay, that's the formula for combination. And in this case, okay, what is the value for n? 8 players. Fine, there are total number of players 8. Among them, a team must be formed of 5 players, but there is one condition, that is not to include a particular player. Okay, so a particular player should not be included. A particular player shouldn't be included, right? That means now we have a choice of 7 players. So 8 minus 1, 7 players. We have a choice of 7 players. Among these 7 players, we need to form a team of 5 players, right? So we have to select 5 players from 7 players. We have to select 5 players from 7 players, right? Hence, required number of ways, required number of ways, that is 7C5. Here n becomes 7 and r equals to 5, right? So how can we write 7 factorial, 5 factorial, 7 minus 5 factorial? Further, we can write it as, look here, if n factorial means 1 multiplied by 2 multiplied by 3 and dot 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 up to n minus 1 and n, the product of n numbers starting from 1. Okay, so 7 factorial means we can write it this way: 7, 6, and instead of 5, 4, 3, 2, 1, we can write 5 factorial. So we are already having here 5 factorial and 2 factorial. So both 5 factorial got cancelled. 7, 6, 2, 1. So 3, the answer is 21. So how many ways a team of 5 players be selected? Option C, 21 is the correct answer. In question number 30, it is given, what is the coefficient of the middle term in the expansion of 1 plus 4x plus 4x square whole to the power 5? First, let me simplify it. This can be written as 2 multiplied by 2x multiplied by 1, 2x whole square whole to the power 5. So this is the expansion of a plus b whole square, where 1 is a and 2x is b. So 1 plus 2x whole square whole to the power 5. Now this can be written as 1 plus 2x whole to the power 10. As we know, a to the power m whole to the power n would give us the value a to the power mn. Okay, so the expression becomes 1 plus 2x whole to the power 10, correct? So here the exponent of the expression is 10, correct? This is a even number, right? This is an even number. So number of terms equals to, if we expand this expression, we will get number of terms as n plus 1, means 10 plus 1 will be 11. There will be 11 terms in that expression if we expand them. So here 11 is odd number, right? So therefore there will be one middle term. There will be one middle term, and that will be the 10 by 2 plus 1th term. So 6th term will be the middle term of the expansion. So how to find that sixth term? Let's say T6. T6 can be written as T5 plus 1. So here R equals to 5, R plus 1. We already know the value, how to find the general term, R, which is in R position, that is NCR. If the expression is A plus X whole to the power n, then a to the power n minus r, x to the power r. That is the formula. We will use the same formula here. In this case, n equals to 10 and r equals to 5. Also, a equals to 1 and x equals to 2x. So here we can write that 10C5 1 whole to the power 10 minus 5, 2x whole to the power 5, right? Let's start with the calculation. 10 factorial, 5 factorial, 5 factorial, it will give me value 1, and 32x to the power 5. Both the 5 factorial got cancelled, and here also 5, 4, 3, 2, 1, 7, 6, 32. So 4 and 2, 8. 2 and 3. So it becomes 2, 3, 7, 6, and 32 multiplied by x to the power 5. Don't take it that I have cancelled 2. No, 2 is there. Okay. So this will give me the value 8064 x to the power 5, right? Since we are required to find the coefficient of the middle term, so this is the exactly middle term, and the coefficient is the constant value which is associated with the variable, that is 8064. So here the correct answer is option A. It is given in question number 31 that if tan x minus 3 by 4 and x is in the second quadrant, then what is the value of sin x multiplied by cos x? Okay, so since x is in the second quadrant, we already know, let me tell you again, that in the first quadrant, all the trigonometric ratios are positive. In second quadrant, only sine and cosec are positive, and rest of the ratios are negative. Third quadrant, tan and cot are positive and rest of the ratios are negative. And in the fourth quadrant, only cos and sec are positive and rest of the ratios are negative. Right. So since x is in the second quadrant, that means sine will give us the positive value, but cos will give us the negative value. Correct. So let's try to find the value for sin x and cos x first. So it's given that tan x equals to minus 3 by 4, right? What is the relation between tan and sec, or tan and sin, and tan and cos? I mean, how come we find out the value for sine or cos from tan theta? So we already know that sec squared theta means 1 plus tan squared theta. From standard identity, we know this value. So in place of theta, we can write it in the same way. If we put x in place of theta, we can write sec squared x equals to 1 plus tan squared x. So from this, we can find the value for sec x, which is plus minus root under 1 plus tan squared x. Let's try to find the value. 1 plus 9 by 16, 25 by 16, right? Since x is in the second quadrant, so obviously sec theta will give us the value in negative. So therefore sec x equals to minus 5 by 4, right? And sec x is the reciprocal of cos x. There, so we can write cos x equals to minus 4 by 5, right? And what is the relationship between cos x and sin x? There is a very famous standard formula, that is sin squared theta plus cos squared theta equals to 1, right? So we can put, to find the value for sin x, we can write plus minus 1 minus cos square x. Let's put the value 16 by 25. It will give us the value 9 by 25. Okay, since x is in the second quadrant, so sin x will give us the positive value. So we will choose the positive sign, means the plus sign, 3 by 5. So here sin x is 3 by 5 and cos x is minus 4 by 5. Let's find the product of sin x and cos x now. That is 3 by 5 multiplied by minus 4 by 5. So the answer is minus 12 by 25. So here minus fraction 12 by 25 means option D is the correct answer. In question number 32, it is given that what is the value of the following? The expression is cosec 7 pi by 6, sec 5 pi by 3. We already know the value for pi, that is 180 degree, correct? So let's find out, since 7 pi by 6 it's given in the radian unit, correct? We need to convert it into degree. Okay, so how can do that? 7 pi by 6, 7 pi by 6 in degree, we can find it as 210 degrees. Same way, let's find the value for 5 pi by 3. 5 pi by 3, 180 by 3, it will give us the value 300 degree. So the expression cosec 7 pi by 6 and sec 5 pi by 3 becomes cosec 210 degree, sec 300 degree. Okay, so here how can we break this 210? 210 degree can be written as 180 degree plus 30 degree, correct? Also this sec 300 degree can be written as 360 degree minus 60 degree. Fine. Okay, let's break it break it down in detail. Like 180 degree means 290 degree plus 30 degree, and also sec 4 multiplied by 90 degree minus 60 degree. Okay, now let me explain you something here. Cosec n multiplied by 90 degree plus theta. Okay, if n equals to even, right? N equals to even. Let's say n is 2. So which quadrant it will denote? First one rotation, say n is 2. So two rotations, we need to check two rotations. The first rotation, it will cross the first quadrant, and another rotation, second rotation. So now the angle is in the second quadrant. Since plus theta, we need to cross the second quadrant also. So cosec is now in the third quadrant, where the value for cosec is negative. In the third quadrant, the value for cosec is negative. So in the third quadrant, cosec will give us the negative value. But since n is even, we will write cosec here. Okay. If n becomes odd, if n is odd, we will write cot. Since n is even, we will write cosec. So minus cosec, it will become here, since n is even, minus cosec theta. So in this case, theta is 30 degree. So cosec 30 degree minus cosec 30 degree. And also let's check it for sec as well. So sec n multiplied by 90 degree minus theta. If n is even, let's say n equals to 4. So 4 rotations, we need to rotate it 4 times. So 1, 2, 3, 4 means fourth quadrant. Already sec is positive in fourth quadrant, and also minus theta. Minus theta means it will remain in the fourth quadrant. It is not crossing it. Either it's not passing to the first quadrant or to the third quadrant, but it remains in the fourth quadrant. So since sec is positive in the fourth quadrant, this will give us the positive value. And since n is even, we will keep it as 6. sec. So sec 60 degree, correct? Sec 60 degree. Now cosec 30 degree means the value 2 minus 2, and sec 30 degree means another 2. Cosec 30 degree will give us the value 2 and sec 60 degree will give us the value 2. So minus 4 is the answer. Okay. Here option C is the correct one, minus 4. In question number 33, it is given if the determinant x13001111x4, if the value of this determinant is 0, then what is the value for x? Okay, so first let me tell you, let's say A is undeterminate and A is denoted as A2, A3, B1, B2, B3, also C1, C2, C3, this way. And we are going to find out the value for determinant A. So how to find the value for determinant A? Look here, when we are writing the corresponding value for the first element, which is A1, we will skip the row and the column, respective row and the column, that row which contains A1 and that column which contains A1. So we will left with this much portion. So A1, B2, C3, let's do the cross multiplication, minus B3, C2. Okay, also plus, after that I will put minus. Now we are going to we always find the value of the determinant in order to a particular row or a particular column. So this time we are trying to find out the determinant for A with the respect to the first row. So here A2 is the next element. So A2. Now skip the row and the column as well which contains A2. That means this column and this row we will skip. So here B1C3 minus B3C1. B3C1. Okay, so plus minus plus. Now what is there in the third position in this first row? That is A3. So A3 multiplied by, we will skip the same row and the column which contains A3. So B1C2 minus B2C1. Okay, so this value will give us the value for determinant A. This is the method, this is the process. So this way we are going to, already the value of the determinant is given, which is 0. Now let me first write the determinant x1, 3, B1, B2, B3, C1, C2, C3 equals to 0, correct? So that means x, okay, sorry, in place of B1, B2, B3, I need to write all those values. Okay, so what can be done? Zero, zero, one, 1x4 equals to 0. So here x, 0 minus x minus 1, 0 minus 1 plus 3, 0 minus 0 equals to 0. Also, we can write it down, minus x square plus 1 equals to 0, x square 1. That means x equals to plus minus 1. So here the value for x is minus 1 or plus 1. Option C is the correct answer. Option C is the correct answer. It is given in question number 34. What is the value of the following? 1031 degree, 1033 degree, and up to 1059 degree. Okay, so let me first tell you that 10A can be written as cot 90 degree minus A. Okay, so this is coming from the complementary relationship. Okay, also cot A can be written as 1 by tan A, right? Now let's write the given expression first. 1031 degree, 1033 degree. Here we are taking all the odd values. Okay, so 1035 degree up to 1057 degree, 1059 degree. All the odd angles we are taken, all odd degrees we have taken. So now 31 degree, 33 degree, 1035 degree, and this 57 degree can be written as cot 90 degree minus 57 degree, also cot 90 degree minus 59 degree, because that will give us the value 1059 degree or 1057 degree from the complementary relationship. We have seen that. So here 1031 degree, 1033 degree, 1035 degree, dot dot dot. Now cot 90 degree minus 57 degree will give us the value cot 33 degree, cot 31 degree. So this way, now with the help of the reciprocal relation, we can write it as 1 by 1033 degree, 1 by 1031 degree. So look, this will got cancels and all the value in between will follow the same way, will got cancelled in the same way. So we will left with only 1. So here option C means 1 is the correct answer. In question number 35, it's given there is a determinant given, which is fx, defined as fx, and then we are required to find the value for the sum of f of -1, f of 0, and f of 1. There are 4 options given. Okay, first let me give you the inside the concept of determinant. I know you already know that. Let's say a be an determinant. It can be defined as A1, A2, A3, B1, B2, B3, C1, C2, C3, this way. If we are going to find the value for A, so determinant A can be written as A1, we are going to find the value with the respective of the first row. So A1, we will skip the row and the column as well, which contain that element A1. So we are left with this portion. Now do the cross multiplication, B2C3 minus B3C2. After that, plus minus A2 B1C3 minus B3C1. Okay, and next plus A3 B1C2 minus B2C1. So this is the expression for finding the value for of determinant A. Okay, so here we are already given with the determinant, that is f of x. Let me first write it, the given determinant. F of x given as 1, 2x, 3x multiplied by x minus 1, x multiplied by x minus 1, 2, x minus 1, x minus 2. Next, x plus 1, x multiplied by x plus 1, x plus 1, x minus 1. Okay, first we will find the value of f of -1. That means in place of x, we will put -1. So f of -1 will give us the value. Let's put everywhere, wherever there is x, we will replace it with -1. So 1, -2, and -3, -1, -1, -1, -1, 2, -1, -2, -1 plus 0, and so it will give us the value. It will give us the value, I mean the determinant, 1, -2, -2, -3, 6. Next, -1, -2, 2. Also, -2, -3. So 6 to the 12. And here we got 0, 0, and also 0. Okay, since as you can see that one column is 0, if one row or one column is 0, so we can say that the value for the determinant will get 0. I can show you by expanding it. Let's try to find out the value for date f of -1. That is, it will give us the value 0. Okay, now let's find the value for f of 0. F of 0. So f of 0 means 1, 0, 0, 0, 0, 2, 0 -1, and 0 -2, and also 0 plus 1. So will give us 0 and 0. That means it becomes 1, 0, 1, 0, 0, 0, 0, 4, 0. Look here, again we are getting one particular row, all the elements at 0. So without wasting our time by expanding the determinant, we can easily say this will give us the value 0, as we have seen here. Next, f of 1. Okay, let's try to find out the value for f of 1. F of 1 will give us 1, 2, 1, 1 -1, 2, 1 -1, 1 -2, 1 plus 1 is 1, 1 minus 1. So this will give us the value 1, 2, 0, 1, 0, 0, 2, 2, and 0. Now look here, all the elements in the third row is 0. That means again it will give us the value 0. So here we are required to find the sum of f of -1, f of 0, and f of 1. So f of -1, f of 0, and f of 1, as we have already proved that individually they are giving us the value 0. That means the sum is also 0. So here the correct option is option A. Option A, that is 0. It is given in question number 36. The equation sine inverse x minus cos inverse x is the value of pi by 6. Okay, so first let me give you a explanation of a very important concept, that is, it is very important information in inverse trigonometry that sine inverse x plus cos inverse x will give us the value pi by 2. You may question me how. Okay, let me prove it. If we can assume that sine inverse x is theta, fine. Therefore, we can write sine theta as x. Okay. And also sine theta can be written as cos pi by 2 minus theta. Okay. So that means it is also x. So from here, we can write cos inverse x equals to pi by 2 minus theta, right? Now let's add this two out, equation 1 and equation 2. So after adding them out, we can see that sine inverse x plus cos inverse x equals to theta plus pi by 2 minus theta. Both theta got cancelled. It becomes pi by 2. So this relationship proves holds true, correct? We are going to use this information in order to solve this particular question. Okay. And also we know cos 30° will give us the value root 3 by 2. Now let's see how can we use this two information in order to solve this. Look here, it is given that cos sine inverse x minus cos inverse x equals to pi by 6, right? Also, we can balance it some way, that plus cos inverse x minus 2 cos inverse x equals to pi by 6. Okay, let's name it equation number 3. So from 3, we can write it as pi by 2 minus 2 cos inverse x pi by 6. The bracket we will write from 3. Okay, here 2 cos inverse x pi by 2 minus pi by 6. So 6 3 pi 6 3 pi minus pi 2 pi by 6, right? So here both 2 got cancelled. We will only left with cos inverse x equals to pi by 6, right? So x equals to cos pi by 3, means cos 30°. We have seen that cos 30° give us the value root 3 by 2. So x equals to root 3 by 2. Therefore, the equation has unique solution. Okay, the equation has unique solution. Option B is the correct answer. What is the value of the following? Sine 24° plus cos 66°. Sine 24° minus cos 66°. Okay. So from the complementary relation, we can write that cos 90° minus theta will give us the value sine theta. Also, sine 90° minus theta will give us the value cos theta. Okay. So here from the given expression, we can write sine 24° plus cos 66°. Also sine 24° minus cos 66°. Fine. Let's use that complementary relation. Cos 66° we can change, or we can write it as sine 90° minus 66°. So in both, the expression we will change cos 66° in terms of sine. Sine 90 degree minus 66 degree, correct? So sine 90 degree minus 66 degree will give us the value sine 24 degree. Sine 24 degree. So sine theta minus sine theta will give us the value 0. So 0 multiplied by something again will give us the value 0. So 0 is the value for this expression. Option B is the correct answer. Question number 38 states that a chord subtends an angle 120 degree at the center of a unit circle. What is the length of the chord? Okay, so let me tell you one important thing. If R is the radius of a circle and theta is the angle from the center of the circle to the 2 points of the chord, to the 2 points of the chord, means a chord is subtends an angle theta at the center, that then length of the chord can be obtained as, then therefore length of the chord can be written as then 2r sine theta by 2. Okay. In this question, it is given that r is 1 because it is a circle of unit length, which radius is unit length, and angle theta is 120 degree. Therefore, length of chord will be 2 1 sine 120 degree by 2. So 2 sine 60 degree. Sine 60 degree gives us the value root 3 by 2. Root 3 by 2. So here root 3 is the correct answer. Root 3 units. So option D is the correct answer here. Question number 39 states that what is the value for the expression 1 plus cot theta minus cosec theta multiplied with 1 plus tan theta plus sec theta, right? In order to solve this question, let me discuss few important formulas from trigonometry. Those are, first, we can write cot theta in terms of sine theta and cos theta, that is cot theta equals to cos theta by sine theta. Also, tan theta equals to sine theta by cos theta. Also, cosec theta is the reciprocal of sine theta. And sec theta is the reciprocal of cos theta. Okay, there is a very important one standard formula, that is standard identities. We rather say that this sine squared theta plus cos squared theta equals to 1. Okay, let's start to solve this sum now step by step. So here it is given that 1 plus cot theta minus cosec theta, 1 plus tan theta plus sec theta, right? So we can put all the values in terms of cos and sines. So here 1 plus cos theta by sin theta minus 1 by sin theta. 1 plus sin theta by cos theta plus 1 by cos theta equals to, let's do the LCM, sin theta, it becomes 1 sin theta plus cos theta minus 1 cos theta plus sin theta plus 1. So look here in the denominator, we are getting sin theta and cos theta, right? And in the numerator, we have sin theta plus cos theta minus 1 in one term, and in another term, there is sin theta plus cos theta plus 1. So we can treat them, this two, as A minus B. If we compare A with sin theta plus cos theta and B with 1, A plus B. So from algebraic formulas, we know this is equals to A square minus B square. Okay, so we can write it as sin theta plus cos theta whole square minus 1 whole square. We can expand this in order to A plus B whole square. We will get sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 sin theta multiplied by cos theta. Also, we have seen that sin square theta plus cos square theta will give us the value 1. So this 2 will get cancelled. Here 2 sin theta by cos theta by sin theta cos theta. This 2 got cancelled. We will only left with 2. So here 2 is the answer. Let's check all the options. Yes, option B is the correct one. In question number 40, it is given, what is the value for the expression 1 plus tan square theta by 1 plus cot square theta minus 1 minus tan theta by 1 plus cos theta whole square? So in order to solve this particular sum, first we will discuss about few standard identities that we need to learn. One is sec square theta equals to 1 plus tan square theta. Also, cosec square theta equals to 1 plus cot square theta. And here, cot theta equals to 1 by tan theta. Sec theta is the reciprocal of cos theta, and cosec theta is the reciprocal of sin theta. Okay, now let's start solving this expression. So 1 plus tan square theta by 1 plus cot square theta minus of 1 minus tan theta by 1 minus cot theta whole square. So here 1 plus tan square theta, we can write it as sec square theta. Also 1 plus cot square theta, we can write it as cosec square theta. Right? Now minus 1 minus tan theta, and this cot theta, we can write it in terms of tan theta again. So 1 minus 1 by tan theta whole square. Cosec square theta, 1 by cosec square theta means sin square theta, and sec square theta means 1 by cos square theta also. So minus 1 minus tan theta and tan theta minus 1. Also the tan theta that is in the denominator will go to the will go to the numerator. So it becomes tan theta. Let's do the whole square. Sin square theta by cos squared theta minus. So here tan squared theta 1 minus tan theta whole square. I'm distributing that square to the every term, and tan theta minus 1, if we take common minus 1 whole square, it will become 1 minus tan theta whole square, right? So it both will got cancelled. This will give us sine by cos theta. Sine theta by cos theta will give us tan theta, and the whole square means tan square theta, also minus tan square theta. So the answer is 0. So here it matches with option A. Option A is the correct answer here.